mathematical composition. I wanna get up on the track like that, wanna spit on the mic and do it just like that. To a beat that I'm speaking, the way that's unique to the beats in the street with a medical heat. When I'm flipping and singing and spitting the venom and giving the sound that ain't nobody bringing. I'm ripping the mic when I'm up in the zone.
I'm about to go beast mode.
Hey everybody, Mr. Enyart here. Today we're doing grade 6 module 1 topic B lesson 15. So module 1 lesson 15. And this lesson is all about a synthesis of representations or equivalent ratio collections. So basically, let's throw that out. So a better way of saying it might just be using equivalent ratios to solve real-world problems and collecting data. So we're just going to, leave that up over here, which means I now have to change the font to something a lot smaller, but that way you can still zoom in. Oh, that's way too small. Let's make it a little bit bigger. Nope, a little bigger than that. Let's go 20. Let's go 30. Let's go 30. Nope, too big. Let's go back down to 24. Nope, that's still too big. Wait, I thought 20. Oh, no, it didn't fit. So, yeah, let's go back to 18. Okay, there we go. And we're just going to shift it right there. So this is what we're doing today. And we're going to use this problem, exercise 6, to summarize the whole lesson. So hopefully it'll make sense when you're done with this. So everything starts with, of course, reading. So also on a news broadcast, a chef from a local Italian restaurant demonstrated how he makes fresh pasta. If you haven't been to Poe's Dumplings downtown by KU Med, they make their own pasta. Amazing, amazing. Anyway, so they make fresh pasta daily for his restaurant. The recipe for his pasta is below. So I want to read this, but then I also want to understand there's lots of ratios in all the recipes we see. And you've seen in my videos I use a lot of cooking and recipes to show ratios because it's such a clear and obvious part of cooking. So 3 eggs beaten, 1 teaspoon of salt, 2 cups all-purpose flour, 2 tablespoons of water, and 2 tablespoons of vegetable oil. We want to determine the ratio of the number of tablespoons of water to the number of eggs. So all we're really focusing here on is the tablespoons of water and the eggs. So I just like to mark that information and make it very clear. And then if we just kind of scroll on down here, we can see that there is, sorry, I didn't realize I was recording right there. We can see that we have a table, which is one way of collecting data, and a graph, which is another way of collecting data or showing the data collected on the table. So if you remember up top, there were 3 eggs for 2 tablespoons of water. And in the table, you can see that when I move from one to the next, all I'm doing here is times 2. So I'm going to also multiply this times 2 to get 6. Then here is times 3, and so on and so forth. And so here you can see that I have filled out my table, and each ratio is equivalent to 2 to 3 because they all grew by the same factor. So now if we want to show that data on the graph, we have to organize it. So they were nice enough to provide us a graph, but did not give us any numbers or labels for what this graph represents. Well, obviously I want one side to be our tablespoons of water, perhaps this one, and one side to be our number of eggs, perhaps this one. I usually do X and Y, so I'm probably going to do water down here and eggs here. And so I just always make sure I do something like this. X and Y, x-axis is the one that goes across, and the y-axis is the one that goes up and down. So now I just have to figure out how to organize my numbers. So there were plenty of lines to just do ones. All right, so on the bottom here, I went by ones because this represents my tablespoons of water, as shown right here. And then this I also went by ones because I only needed to go to 18, even though I did go to 16 because I saw this over here for the water. But I only need to go to 18 according to this table, so this is my number of eggs. And so now I have my number of eggs on here label and my tablespoons of water table. I don't know if that's right for tablespoons, but I'm using that. And it's just a matter of now plotting the points. So I'll show you how to plot the first one, 2 to 3. So that's 2 tablespoons of water. So here's the 2. And it's 3 eggs. So I go from 2 on up to 3, and I'm going to put it right there on that dot. And I just like to, there it goes. It's not really perfect, but I can adjust. So I've plotted my points, and I know they're not all completely perfect, but, you know, technology, this one should be down just a hair. But this is at 2, 3. This is at 4, 6, 6, 9, 8, 12, 10, 15, and 12, 18. So now I can answer the rest of the questions, which are how many eggs would there be if there were 16 tablespoons of water. And I can keep following the graph, which is one method. I could also just come over here and, I mean, it says demonstrate on your graph, but I could also just use a table. So on the table, I can see it's going to be 24 eggs. And on here, what I would do is I would draw a line connecting all of these. And I would probably want to renumber my graph, because when I get to 16, I'm going to be way up here outside of my graph. If I went by 2s here, then I would have been able to fit. So I'm gonna show that. I'm gonna change these and go by 2s, and then that is going to change when I get to 16, that it will actually fit here on the graph. So you can see I changed the this side to 2s. I could have gone by 3s, obviously, and I could have done these by 2s, and that would have saved me a lot of room. But I like to spread my graph out as much as possible. And so 2 to 3, 3 is halfway between 2 and 4, but then 4 to 6 lands right on the corner. And so you can see on my graph, I would just keep that line going, and when I get to 16, right, I would be at 24. And so that matched there. So you can see that I can now answer that question at 24 eggs. So before we go, just to remind you, the lesson summary and the problem set is always on here, and I'd love to answer questions about this. So feel free to like the video, subscribe, send me a comment, or if you want to message me directly, you can look me up and email me at my school. Those who have my information can do so. There are several ways to represent the same collection of equivalent ratios. These include ratio tables, tape diagrams, double number line diagrams, equations, and graphs on coordinate planes. So today we focused on these graphs on coordinate planes, and we focused on the ratio tables. Now remember the tape diagram. If I wanted to do 2 to 3, would just be like this, right? And then I can show equivalent ratios by saying, instead of this being worth 2 and this being worth 3, meaning each unit is 1, I can change it to a let's put a 5 inside of here, right? Each box represents 5 now, and I still see 2 boxes and 3 boxes, but now I have a 10 to 15 ratio, which of course would be still a 2 to 3 ratio. And then the double number line is when you have 2 items you're comparing and they line up and spread out by the same amount according to the ratio you started with. So you can see I have 2 to 3, which is equivalent, and so I spread them both out equally, but this one counts by 3s and represents this set of boxes. This one goes by 2s and represents these boxes. So you can see when I get to 10, I'm at 10 to 15, 8's from 8 to 12, 12 from 12 to 18, and this will always work as well. And of course, we always have equations. Equations are simply using the multiplication. And a lot of us we're good with numbers, so we like to just use the multiplication. But if I have a 2 to 3 ratio and I say that I'm going to make this number down here 15, all I have to do is figure out that 15 divided by 3 is 5. So I'm multiplying by 5, and therefore I'm also multiplying this by 5, making it a 10. So 10 to 15 would be that ratio. Hope that helped. Lesson 15, Module 1, Engage New York / Eureka Math, Mr. Enyart. Catch you later.
I'm ridiculous when it comes to these mathematical compositions. I wanna get up on the track like that, wanna spit on the mic and do it just like that.